Okay, so let's start with the geometry node and a Bezier curve along the z-axis. Okay, we can always go back and change it. Resample the curve and revolve around the z-axis. Maybe with 40 subdivisions. Okay. Now let me change the basic curve. Edit. Okay, maybe like that. Okay, something like this. Okay. Now let's use a mountain just to give it a little bit of noise. Not that much. Just a little bit. Okay. So now the craters. The technique that I'm gonna use now is very well illustrated by the always useful Entagma channel. This is the video, Boolean denting. I strongly suggest that you take a look at it because it's very well done. I'll put the link in the description. So let me create a sphere, a polygon sphere with some frequency, and let's move it where we have intersection with the original surface. Something like this. Okay. Then a bit higher. Okay. Now, the first step is to create the SDF for both surfaces. VDB from polygons. And let's use 0.01 as voxel size for both. Okay. So VDB base and VDB sphere. Now we want to expand the surface with the VDB reshape SDF. Expand means that we offset the surface by 4 voxel. You see the difference here? Okay, and the same for the sphere. So this is expand base, expand sphere. Now let's take the intersection, VDB combine intersection, expand intersection, and from here we can remove the original sphere, VDB combine difference, and now we have a shell. Okay, and we can also remove the expanded sphere from the original surface. PDB combine the original surface, expanded sphere, difference. Okay, and now we just need to combine these two. With a SDF union. Okay. PDB smooth. Something like this. Okay. And finally, we can convert everything into polygons. Convert PDB. Polygons, and we have the crater. Now we want more than one crater over the surface, and the idea is to scatter some point and use a copy to points to create multiple spheres. But if we did it now, we would have craters also inside the worm, and I don't want that. So the idea is to use the curve view attribute of the resample node. Curve view. Okay. Now, sorry. The scatter node requires a primitive group, not a point group. So we have to promote the attribute, let's say after the mountain. Attribute promote. Curve view from point to primitive, and we should see something now. Curve view. Now you see that we have, oh, there is a problem here, maybe minimum. Okay, we have a curve view attribute going from 0 here all around the surface to 1. 1 is the red one here. So we can say group expression let's call the group scatter zone, and the expression is at curve view greater than 0.1 and at curve view less than 0. Let's say 5. Let me see. Okay, not bad. Maybe just a little less. 0.45 and 1.15. Okay, this is our scatter zone. Now you can use that to scatter some point. Scatter zone, okay. Let's say 10 points. Okay. So now let's use a copy to points. This is the, okay, the sphere. Let's use the original sphere, but remember to reset the center to 0, 0, 0. Sphere. We have the spheres. Let me see if it works. Yes. Okay. Okay, now for the vein system, we will use the craters as obstacles. So we need an attribute telling us where they are. And so we can use a attribute transfer. let me create the attribute create. Let's call it craters. Default value is 0. Okay, so we have 0 here. And the same for the copy to points. Attribute create craters with value 1. Now we can transfer the craters attribute with blend. Let me visualize the attribute. Okay. Something, yes, it's fine. Maybe we can blur just a little bit. Attribute blur. Okay, seems fine. Okay. Now, I would like to see a more accentuated borders here. Maybe we can increase the expansion here. 5 and 5. Yes, okay. Now let's apply another mountain, but this time animated. After all, this is supposed to be an organic creature, so this should help selling the effect. 0.03 animated. 2. Yes. Even okay. The last step for this video is to create the path animation. So let's start with a curve Bezier, and from the top view we can draw something. Okay, resample. Oops. Okay, and let's use a point VOP to apply some noise. So we are going to add to the current position some noise function, anti-alias noise position, and we want the noise to be mainly on the X Z plane. So we can split the coordinates with the vector to float and float to vector. So X in X and Z to Z, and for the Y we can multiply by a constant, let's say 0.25. Okay, so now we can apply the noise to the position. Okay, and the noise is 3D, and let's promote some parameters: frequency, offset, amplitude, and roughness. Okay, No, this is obviously too much. Let's reduce the roughness. Be 0.1, okay, and the frequency, okay, maybe even less. And let's try. Pat the form. Okay, we have something. Okay, you can play with it as much as you want. It's really non-important right now. So, see you in the next video.